of the atom. Previously we have seen that substances or matter is further divided into molecules, and the molecules is further divided into atoms. Atoms and molecules are the fundamental building blocks of a matter. That means they are the major resources, or they are the major basic particles of a substance or matter. Now let us see, there exist different kinds of matters, right? There are different types of substances having different chemical properties. These properties or these substances differ from each other by mainly due to the atoms and molecules within the substances. That is, the molecules or the atoms differ from one substance to the other substance. That is, the chemical nature or the composition of atoms is different from one element to the other element. Therefore, we can see that what are the changes or what makes the atoms differ from one element to the other element, and is that atom is again divisible or atom consists of subcomponents. Let us see all these questions in detail in this chapter, and let us see that atom consists of subatomic particles. But previously the scientist known as Dalton has said that atom is undivisible or atoms is indivisible because atom cannot further be divided. He has said that, Dalton, the great scientist, has said that it cannot be divisible. But during 19th century, the scientist has faced a great challenge on them, that is how to produce or how to give or how to analyze the structure of atom and the important properties of atom. Therefore, we can say that the charged particles in a matter. Let us see the charged particles in a matter. For example, let us take a comb and let us comb our hair, that is our dry hair, with the help of a comb. Then you bring that comb near to the small pieces of paper. I hope everyone will be doing this practice in practical life also. Just take a little time and do this practically, and you will observe that the comb will attract the small white pieces of paper. That is because it gains the attractive force by rubbing of comb with our hair. And also another example, like rub a glass rod with silk cloth. When you rub a glass rod with a silk cloth, the silk cloth will attain some forces, that is attractive forces, and these forces, when this silk cloth is brought near to the, that is rod and silk cloth, when rubbed, there will be forces on them, and when this rod is brought near to the inflated balloons, that is inflated balloons means the gas is hydrogen gas in those balloons, and when those balloons are brought near to this wiped out rubbed off rod, then it will be burst off. That is due to the forces between them. These all are due to the reason because they are charged up during the rubbing time. That is, we can say that atoms and molecules can be charged. That means they allow the electricity to pass through them. Let us see the charged particles in a matter. For example, let us take a comb and let us comb our hair. Then let us bring that comb near to small pieces of paper. Then the comb will attract those small papers, right? And let us take one more other activity, that is when you take one rubbery two objects. That means take a glass rod and when you rub it with a silk cloth and when you bring it to near a magnet, it will be attracted. This is because the attractive forces are the charging of the particles in a substance. That means on rubbing two objects together, when we rub two objects together, the forces will be developed, and those forces leads to the attraction of the substances, right? And they become electrically charged. Therefore, we can understand that the substances or the particles are electrically charged. That means an atom is consisting of some other hidden particles in it. By those forces, they are getting the charge, right? By this we can say that atom is divisible. That means previously according to Dalton's theory, we have studied that atom is indivisible, right? Because and it is indestructible, means it has no further smaller parts in it, right? But according to this activity, we can say that some more charged particles or some more attractive forces are hidden within an atom, right? Therefore, we can say atom is divisible. And now let us see what are the hidden particles or subatomic particles within an atom. Now let us see a great scientist known as J.J. Thomson, who had discovered the subatomic particles within the atom. These are electron and proton. He has justified that an subatomic particle known as electron with negative charge is acting as a charged particle within an atom. That means I can prove here like this. He is a scientist. He has done an activity known as that is positively charged radiations. That means according to E. Goldstein, the one more scientist E. Goldstein had also done some discoveries over the atom. Is there any particles are there? All the scientists have faced in 19th century a major problem. What is the structure of atom and what are the hidden particles in the atom? All these scientists were trying and they were finding out some properties, and some theorems were failed, like Dalton's atomic theory and all. And now J.J. Thomson has declared that a model known as atomic model, Thomson model of atom. Now by this model he is saying that an atom consists of electrons and protons. As for example, let us take a watermelon, right? A watermelon, when we cut into two pieces, we will be getting one red color, that is whole space occupied by that, and in between we will be getting that black seeds, right? Now he is describing this model as the red thing what is surrounded whole of the watermelon as protons, and the black seeds which are in between those are known as electrons. And these protons and electrons are positively charged. That means they are having opposite and equal forces. That is, if proton is acting as positively charged particle, whereas electron is acting as negatively charged particle, right? Now by these two opposite and equal forces, they are balancing in an atom such a way that atom is not collapsed. Thus they are maintaining an atom in collapsing state, right? Now let us see the mass of proton and electron. The mass of proton is defined as 2000 times greater than or equal to mass of electron. Therefore mass of electron is inlet. It is not considered, right? It is inlet. It is not minute, right? That's why it is not considered. And now the unit of charge is declared as mass of proton, and the charge is +1 per proton, and for electron it is negatively charged, that is it is taking the value of -1, right? Now there's both scientists, that is J.J. Thomson and E. Goldstein, has done all these experiments and they have reserved or they have declared that atom is divided and it has subatomic particles. Right, now we will be seeing that Dalton's atomic theory in unit 3 previously I have explained. In that we have studied that atom is indivisible and indestructible. That means it cannot further be broken. But this theorem has been failed by the help of J.J. Thomson. Now J.J. Thomson have proposed a model in order to see the structure of the atom, and we have seen that with the best example, that is watermelon and Christmas pudding, right? Now let us see other models what the scientists have described for the structure of atom. One more model of the structure of atom, that is Rutherford's model of an atom. The great scientist known as Ernest Rutherford also given a model for the structure of an atom. Now let us see the activity what he had done. That is, he has taken a thin layer of gold foil, because why he has taken a gold foil means it is the one which is having a minimum thickness or least thickness in layers, right? Therefore, he has chosen gold foil, and it consists of around 1000 atoms in it, and the alpha particles, the particles which are doubly excited and is equal to helium ions, that means the alpha particles or alpha radiations, that is we will be seeing in all the hospitals right now, that is during the x-rays and all, they will be releasing that UV rays and alpha rays, all those rays they will be using, and these alpha particles are energized by using the helium ions, and now they are getting the charge or mass of 4 units, and these alpha particles are exposed or released over the gold foil. This is the small pictorial representation of gold foil and the experiment, and just assume that these circular parts or these circular ones are atoms, and these are around 1000 atoms assume, and these rays are known as alpha rays, which are generated or which are explored or which are passed around this gold foil. And now let us see the observations what will be done. Some alpha particles are deflected and some alpha particles are penetrated and which are passed away in a straight line, and some alpha particles are passed or taken an angle of 180 degrees. These are the observations what he has seen during this activity. But as actually we know that alpha particles are having much heavier weight or much heavier mass than proton, right? Now, therefore, now let us see this. The fast moving alpha particles have been penetrated towards the atoms, and the weak or less slowly moving alpha particles at some points have been deflected, and one alpha particle in 12,000 has rebound, that means it has taken 180 degrees and it has collapsed, or it has oppositely, when we throw a ball in forward direction, it will be rebound, that means it will be taking 180 degrees and it will be reversed back towards me, that is known as rebound. And one alpha particle around 12,000 had rebounded, and these are the observations he had done, and by these observations he had made or he had given some conclusions towards the structure of an atom. But let us take one small example or practical example in order to get a brief understanding or detailed understanding about this activity. Let us take one child who is standing in front of a wall, and let us say or let us suppose that the boy is closing his eyes and he is throwing the stones towards the wall. Now, whenever he throws a stone, he will be hearing the voice or sound of that stone, right? How many times he throws, that many times he will be hearing the sound. If he throws 10 times, he will be hearing the sound 10 times, right? If suppose we take a blind child or anyone near the fence, that means it is a thin wire fencing we will be giving for walls for protection sake, right? If we make him to stand near a thin fence wire and let us make him to throw the stones, will the sound comes every time when he throws the stone? No, because sometimes it may hit the thin wire, but sometimes it may not hit the thin wire and it may go from the gap or the space between those fences, right? Therefore, by this Rutherford had concluded that an atom is having a lot of space. That means the particles, subatomic particles, that is protons and electrons, in between those there is a lot of space. That's why alpha particles, most of alpha particles have been penetrated without any deflection. And second point what he given is the positive charge occupies little space. That means he has concluded that the positive particles, that is protons, are concluded or concentrated in a small portion of an atom, because only some alpha particles have been rebounded, right? That means the nucleus or positive charge, the positive charge is named as nucleus by Rutherford, and those positive charges are concentrated in a little volume of an atom, and he has justified that it is concentrated at the center of an atom. And at the same time, the third point what he concluded is the atoms or alpha particles rebounded about 180 degrees because of due to less concentration of nucleus. And the third point is the positive charge occupies little space, because only little deflections have been taken place, right? Only 2 to 3 alpha particles have been deflected. Therefore, he has concluded that the protons will occupy little space or have been occupying the little space in an atom. Therefore, this is the pictorial representation or the structure of an atom given by Rutherford. That is, let us take it as a circular atom, the shape of an atom as circle, and he assumed that the nucleus or positively charged particle is concentrated at the center and an electron, that is the negatively charged particle, is rotating in a particular orbit in a circular manner towards the nucleus. That means the center will, for this I can give a best example, that is sun and planets, right? The sun will be concentrated at the center or its position is centered, and the planets like Jupiter, Earth, Mars, everything will revolve around the sun in a particular orbit or in a particular position, that is axially, right? The planets will revolve themselves and at the same time they revolve around the sun. As that is a good example, we can understand how the electrons will revolve around the protons, that is nucleus, right? Now, the drawbacks or the negatives or failures of Rutherford's model is, suppose any electron is revolving in a circular manner, then it exerts acceleration, right? The moving particle will be getting acceleration, right, because of velocity, and therefore the acceleration will result into radiations of energy. That means any acceleration particle will radiate some energy. Therefore, the energy is lost. That means electron will be continuously losing its energy due to its revolution towards the nucleus. Therefore, at some instant, the electron will be losing completely its energy, or it will lose its energy, or it will exhaust itself, and it will jump or fall into nucleus. Therefore, the atom should be unstable, right? Atom should be collapsed because the electrons and protons are mixed up. But if the atom is collapsed, is there any matter in the surroundings? Is the matter exist? No, because the matter is existing in our surroundings because atom is stable, right? Therefore, we can conclude or we can say that the drawback of Rutherford's model is, according to his theory, the atom is unstable, but the atom is really stable. That's why all this matter, all this chair, everything, air, everything are existable, right?